It looks like a door. There's a bit of perspective. It's a perspective picture of a door. But a house door frame won't be framed right around it. The door will go through to the floor there. But it could be a safe, in which case that would be the combination dial in the centre. And to open up a safe, you need a combination. And the combination to the safe are those numbers there. It's just a matter of how. It's on ratio. It's 0.9. The sides of the rectangle here are not reading on ratio because it doesn't matter. It's six split, 60 degrees, 30 degrees, apart from one axis which has been adjusted around another 20 degrees. There's a jet engine going overhead. 360 divided by 40 is 9. So I think that could be indicating 9 split because of this 9632, which is the cube of 9869. And there's 3 9869s to form the cube, which is 9632, which I suspect is 9 split ratio, but I'm not sure. I'll have to look it up. Anyway, to understand where these numbers come from, to understand what they mean, we have to do something. And that is to convert the calibration of the inverse square law from numerals and fractions to something that's got a point in front of it. The strength of the radians at 3R is 1/9. And to convert that to a decimal, divide 100 by 9 to give 1111 recurring. Now over here I've got a 10R to 9R situation going on. So the 9R is 90% of the 10R. One thing worth noting is that that square there is not, it doesn't come right into the square because you're losing 90% on both sides. But the area is 9 by 9, which is 81, or an 81st, and 100 divided by 81 is 123. So the strength of the radiance at 9R is 0.0123, that of the 1 square, and at 10R it is a 100th. It's 0.01, the strength of that, of the 1 square. And there's lots of mathematics in here. There's lots going on. But it's the ratio we're looking for. So we're going to go in there. 123 is the radiant strength at the square that is at 9R to 10R, or 90% to that one. And the strength of the radius at the 10R is 100.01. What I want is to split that distance, which I'll do at the square root of 0.99487, and that's going to land me absolutely logarithmically halfway, and then I can chop up the rest of the distance with these numbers over here, coming down to at one point 9869, which is the square of pi. So pi's in there somewhere, maybe as it relates to the area of a circle, but it's the ratio we're after, because that's the ruler, that's the measure. And the strength of the radius at 0.9487, it's going to be the square of 9487, which is 90, and that's a 90th, but 90, 100 divided by 90 is 0.0111 recurring. And that makes the whole thing inverse logarithmic and inverse exponential. And as I say, well, there's a lot of math, but just to try to cut to the chase, I'll load the calculator up with ones like that. Then hit the x squared button, equals 1, 2, 3, 4, 5, 6, 7. So our 1, 2, 3 is a recurring number as well. Now here's the trick. Here's the thing is, I'll now multiply that by 0.9, and we'll see what we get. Well, I think we can safely get rid of those. That's just not enough decimals. We're back where we started. And if I continue, that's 1. That's 9. That's 90. That's 81, and so on and so on. And that's how the ratio is written. This is what I think the crop circles mean by the sides of the rectangles not mattering, because it's these parallel lines here on which you can get a reading for the ratio. And of course there's quite a lot of rings and quite a lot of ratio to be read. This is a propeller. It's a manifestation that occurs out in the rings of Saturn, and it's a mystery as to why. I get a feeling you might have rings with current going in opposite directions, and that this is a spark between them, but I can be no means sure of that. The white dots in the foreground are very common in the ring area. You see them on lots of photographs, lots of images, and maybe one of those got stuck in the rings, and the two rings used it to arc, something like that. I did a couple. This one I just dropped in at 4.3, and I was aiming for the propeller, but I missed just a bit. Maybe that leading edge just there. I don't think it matters. I can't see how that would matter. But what I did find was that this ring in the center is exactly halfway between these two gaps on the inner and outer sides. So measuring ratio of the rings with this method and the gaps are a vast vista waiting to be discovered.